Hey fellow game enthusiasts, it's time for my monthly research video, Top 10 Free-to-Play Citizen Science Games. Playing these games will have lasting, real-world impact and benefit scientists and researchers thanks to your gameplay. Most of these videos I'll let the original researchers speak out of respect, but clips I needed to speed up for time's sake I'll do my best to summarize.
Phylo is all about aligning DNA sequences. DNA is constituted of 4 types of nucleotides, each represented by a different color. They can move left and right, pushing each other when necessary, but they can't swap positions. You can select many puzzle pieces at once, and move them by holding Shift and clicking to draw a box around the blocks. Your score depends on how you arrange the nucleotides. You will be competing against other players in the community and the computer. The computer's score is called par score, and you can see it here by clicking on Stats. You might be wondering, though, how exactly is the score computed? The goal of the game is to maximize the matches and minimize the mismatches between the DNA sequences on the game board and the ancestral sequence. You can see the ancestral sequence by hovering over the node linking the 2 compared species, in this case, the human and the mouse. Let's move over all the nucleotides to the left and take a closer look at the scoring scheme. This is a match because both blocks on top of one another have the same color, which is blue. This earns you 1 point. This is a mismatch because the blocks have different colors. This will cost you 1 point. If I move over the nucleotides to the right, I'll create a gap. Gaps are bad. They represent mutations. In fact, the technical term for gaps is indel, short for insertion or deletion in the genetic code. You have to avoid them. Opening a gap costs you 5 points, and extending it further costs you 1 point per nucleotide shifted. Sometimes, opening gaps is worth it, since it offers you a good alignment with many matches. See here, I shifted everything to the left and wound up with a total of 14 matches, 7 mismatches, and 1 indel. That makes 2 points. But there's a place for improvement. If I choose a more appropriate place for the indel, say here, I compensate for the gap by increasing the number of matches. The scores computed with each comparison are then added to make the final score. Have fun playing Phylo. Remember you're contributing to science, so get those high scores rolling.
Eterna is a puzzle-solving game that reveals the mysteries of one of the most powerful molecules in biology, RNA. RNA is the companion of DNA, taking genetic information and putting it to work inside our cells by folding into complex structures. Smart RNA has the potential to transform medicine, tackling some of the most prevalent and deadly diseases on the planet, like tuberculosis, malaria, and cancer. But scientists don't fully understand its behavior. That's where Eterna comes in. Players use the 4 nucleotides that make up RNA to design a pattern that forms into a target shape. As they progress, the puzzles become more complex, and the challenges reflect the mechanics of nature. After gaining experience, players reach the lab, where their designs are manufactured and tested at Stanford University, often tens of thousands at a time. The experimental results are then returned to the players, so they can improve their designs and become scientific collaborators, joining professional scientists on the frontiers of biochemistry.
Quoted from Wikipedia, EyeWire is a game to map the brain from Sebastian Sung's lab at Princeton University. This citizen science, human-based computation game challenges players to map retinal neurons. EyeWire launched on December 10, 2012. Over 5 years, 250,000 people from 150 countries have signed up. The game utilizes data generated by the Max Planck Institute for Medical Research. EyeWire gameplay advances neuroscience by enabling the reconstruction of morphological neuron data, which helps researchers model information processing circuits. Anyone with an internet connection can participate by solving 2D puzzles to fit together segmentation produced by artificial intelligence used to map the connectome. In EyeWire, players reconstruct 3D models of neurons from electron microscope images by solving puzzles. Playing requires no scientific background. Based on Sudoku and matching games, as well as the kinds of errors that crop up while quantum computing, this seemingly simple puzzle game has helped researchers tackle the best strategies to overcoming errors. You can just play it for fun, or you can use it to conduct scientific research in the field of quantum error correction. These are the puzzles that need to be solved to keep quantum computers free of errors. Researchers need to work out the best way to do it. By becoming a master of the game, you could help build a real-life quantum computer. Check out their website for more details on the science behind the game. This app was developed by Dr. James Wooton, a quantum error correction researcher at the University of Basel. It is supported by the NCCR QSIT. The gist of the game is as follows. Pairs and sets of numbers, called errors, which add up to multiples of 10, are distributed among the puzzle grid. Your aim is to drag nearby numbers together to clear them from the board. Acting fast is key though, as natural errors start to pile up, and mistakes like pulling pairs apart or making an incorrect match generates multitudes of additional errors. If you're having trouble, you can change colors of the numbers to figure out where the sets are, which is especially helpful later on. The game is lost when too many errors fill the grid. There are 3 game modes: Tutorial, which is as it sounds, Z10, which is regular numbers, and the much harder Phi Lambda, where numbers are represented by the 2 symbols Phi, standing for any number that isn't 5, and Lambda for 5s.
Están los asteroides en la aplicación de Cazasteroides. Ya sabéis, podéis usar o el móvil, tener la aplicación en el móvil, o también podéis tener, que es a lo mejor más cómodo, la aplicación a toda pantalla en el ordenador. Lo que estamos viendo es la superposición de 5 imágenes consecutivas, con lo cual las estrellas van a estar fijas, como veis en la pantalla, y en caso de que haya algún asteroide se va a mover. Vamos a ver cosas que no son asteroides. Por ejemplo, hay toda una serie de puntitos blancos, aquí vemos uno, que evidentemente no son asteroides, no cumple varias de las características de un asteroide. Primero, no tiene apariencia estelar, son puntitos mucho más brillantes, y segundo, no hay una sucesión de puntitos que se mueva de forma uniforme en la imagen. Concretamente estos son rayos cósmicos. A veces también veremos puntos negros, pero que tampoco un punto negro no puede ser un asteroide. Son bueno, pues, lo que se llaman píxeles muertos de la CCD. Vamos a buscar lo que serían los asteroides. Vale, aquí tenemos un asteroide. Claramente se está moviendo de forma uniforme, tiene forma estelar y además, ya si hilamos muy finos, podemos ver que está un pelín alargado. Bueno, pues todas estas características hacen que sea un asteroide. Una vez localizado el asteroide, vamos a tener un zoom con un puntero que lo moveremos o con el dedo en el móvil o en este caso con el ratoncito, y lo que tenemos que conseguir es que esté perfectamente centrado el asteroide. Ahora estaría perfecto, ¿de acuerdo? En la parte de abajo estamos viendo cómo el asteroide se mueve, el punto coincide con una de las imágenes, y en la parte de arriba del zoom está perfectamente en el centro de la cruz. Nada, lo seleccionamos.
Cancer Crusade is a treatment management simulator that helps cancer researchers develop the best strategies for treating various types of cancer. Managing a good treatment schedule and increasing your score will help researchers at Moffitt Cancer Center in Tampa, Florida, develop new and improved therapeutic schedules for real cancer patients. The goal of the game is to keep the cancer cell on screen from growing out of control or spreading. The UI for the game is a simple pixel art window that shows the cancer cell you're treating, the part of the body you're treating, or a story doctor to talk to. In the first two, a graph with your treatment schedule is shown, and you can learn from your end score on how to improve. This game is unfortunately only available on mobile. Quite a few of the games that originally inspired me to make this list, like Genes in Space, are sadly no longer available, as their projects have found what they needed and therefore been terminated. So instead, I'm listing these two and an additional honorable mention not as independent game entries, but as websites of research groups that have multiple games available, and will sometimes show games under development. For example, ScienceAtHome, whose game is featured as the first entry in this top 10, has multiple physics games available that are both challenging and fun. They show projects that are in beta and may even accept enthusiastic and knowledgeable beta testers. Zooniverse is another site that features a ton of games. Although some of the games are not directly impacting research just by playing them, I strongly recommend any of their space games, which for the most part are. Your achievements in some of those games might even get astronomical bodies named after you, so go forth and discover new asteroids, star clusters, and exoplanets. My honorable mention doesn't benefit research and isn't technically even citizen science, but it can be used to give financial aid to areas of research. Be the Swarm is a group of alternative games from the mainstream versions, where they take ad revenue from the game and donate it to available charities of your choice. There are only a few games to choose from, but now you can play these kinds of games and know, like the rest of this list, that your playing games has made a real and lasting impact on the world. And people say playing games is pointless. Time to go prove them wrong.